Hey everyone, today we're going to talk about something that's, well, everywhere. It's a concept that connects the music you love, the way you see the world, and even the deepest secrets of the cosmos. We're talking about the universal language of waves.
So here's the question for you. What do a synthesizer, a single electron, and the absolute edge of the universe all have in common? I know it sounds like a setup for a really weird joke, right? But the answer connects everything. Waves. Let's dive in.
Now, before we get to all the mind-bending stuff, we have to start with the basics. So, what is a wave, really? Well, at its heart, it's just energy on the move.
And there are basically two ways that energy can travel. First, you've got longitudinal waves. Just picture pushing the end of a slinky. The compression moves forward, parallel to the direction of the push. Then you've got transverse waves. This time, you're shaking that slinky up and down. The wave moves along the slinky, but the vibration itself is perpendicular to it. That's it. Two simple movements that explain so much.
And you see these two types literally everywhere. Sound, for instance, is a longitudinal wave. It's just compressions of air molecules hitting your eardrum. But the light coming from your screen right now, or the ripples you see on a pond, those are perfect examples of transverse waves.
So here's the absolute key takeaway. Whether it's that slinky, the air, or the water in the pond, the medium itself doesn't actually go anywhere. The water molecules are just bobbing up and down in place. What's actually traveling across the pond is the energy. That is the fundamental truth of every wave.
Okay, so we've got the basic physics down. Now, let's see how these simple rules can be used to build something incredibly creative. Let's talk about how a deep understanding of waves gave birth to the sound of modern music.
You know, back in the early days of synthesizers, they had a bit of a problem. As one of the pioneers, John Chowning, put it, the sounds just felt, well, lifeless. They were static. They didn't have that rich, changing quality of a real instrument because their wave structure was just too simple and never changed. Chowning's solution was just brilliant, deceptively simple, really. He realized you could use one wave to control another. You start with a basic wave called the carrier, then you use a second wave, the modulator, to mess with its frequency. And the magic part? Depending on how much you modulate it, that's the index, you can control exactly how complex and interesting the final sound becomes.
And what's so cool is that this whole process isn't random at all. It follows these beautiful, predictable mathematical rules. Each one of these simple curves you're seeing here is like a single, pure ingredient in our recipe for sound.
But when you combine those simple ingredients, you get this: a ridiculously rich, complex, evolving landscape of sound. All of that complexity, all of that life, comes from those few simple rules.
And that was the game changer. All of a sudden, synthesizers could create these amazing, dynamic tones that sounded like real instruments. Bells, brass, pianos. You know that iconic electric piano sound from the 80s? Or the sharp attack of a synth horn? Yup, that's all thanks to the beautiful math of one wave shaping another.
It's a really powerful idea, right? Using simple waves to build up something complex. But it makes you wonder. It leads to a much deeper question. What if this isn't just a clever trick for making music? What if reality itself is synthesized by waves? And just like that, we leave the recording studio and step into the profoundly weird world of quantum mechanics, where the very idea of a wave gets turned completely on its head. At the very heart of quantum physics is something called the wave function. But here is where it gets bizarre. This isn't a physical wave like a ripple in water. It's a wave of pure possibility, a wave of probability. It describes what could be, not what is.
This was an incredible insight, thanks to the physicist Max Born. He realized the wave function doesn't tell you where an electron actually is. No, it just tells you where you are most likely to find it. The bigger the wave is at any given spot, the higher the odds of the electron being right there if you decide to look.
So just stop and think about what this means for a second. Before we measure it, an electron doesn't have one specific location. It exists as a kind of blurry cloud of potential, a wave of possibilities. The very act of observing it, of measuring it, forces that wave of possibilities to collapse into one single definite point. It becomes a particle because we look. This is the foundation of our entire picture of reality. Okay, we've gone from a slinky to the sound of music all the way down to the fabric of reality itself. So let's take this one last final step. If the whole universe is described by waves, is there a limit?
I mean, is there a highest note in the symphony of the cosmos? Is there a shortest possible wavelength? A frequency so high that you just can't go any higher?
Well, according to theoretical physics, the answer is yes. Yes, there is. And that's it, the Planck frequency. That is a number so ridiculously huge, it almost loses all meaning. It's a 1 followed by 43 zeros.
And just to give you some kind of perspective here, the most energetic gamma rays we've ever detected are way over on the left. The Planck frequency is over a trillion times higher than that. It completely breaks the scale. It's not even in the same ballpark. It's in a different universe.
But this isn't just some random giant number. The Planck frequency corresponds to a wavelength that's the size of the Planck length, which physicists believe is the absolute smallest meaningful unit of distance possible. Any smaller than that, and our ideas of space and time literally fall apart. This is it, the absolute limit. So just look at the journey we've been on, all by following this one single idea. We started with a simple slinky, just moving energy around. We saw how that could be used to create complex, beautiful art in a synthesizer. Then things got weird, and we saw how waves describe the probability of reality itself. And finally, we found the ultimate boundary, the physical limit of waves at the edge of the cosmos. From a simple toy to a synthesizer, from a single electron to the entire universe, waves are how the universe writes its story. They are energy, they are art, they are reality. And that just leaves us with one final thought, doesn't it? If this truly is the language of the universe, what else is it trying to tell us?